In 1962, Gerald Bull would try to turn science fiction into fact. He persuaded the U.S. Army to ship the Navy's biggest cannon to the Caribbean island of Barbados. The U.S. Army and a Canadian university were funding Bull's bold experiment to launch a satellite into orbit from a cannon. Bull first intended to shoot this scientific probe into the upper atmosphere. The nose cone held an unusual payload, a tiny radio transmitter. The needle nose and fins made it more aerodynamic. The probe weighed 475 pounds, but behind it, Bull rammed 740 pounds of propellant. That's enough to fire a shell weighing 1.5 tons. Would the enormous blast destroy the slender probe? Many scientists thought so. January 1963. Back in Barbados, the countdown had begun. The fate of the whole project hinged on this first firing. No one knew if they were about to witness a launch or an explosion. The probe shot out of the cannon at 2,400 miles per hour. It sailed up 16 miles before falling back to Earth. And the radio transmitter worked.
Looks like we had a fully successful launching. The gun's in excellent condition, performed very well.
The HARP project had passed its first test, but the scientists needed to go higher. So they added more propellant to create higher pressure inside the barrel and shoot the probes out faster. The probes went up higher. 30 miles. Then 55 miles, higher than any cannon had ever fired. But Bull wasn't satisfied. He needed to go to space, which was twice as high. But he'd reached the limit of pressure his barrel could withstand. So Bull and his colleagues took a daring step. They welded another barrel onto the original gun. No one had ever built a cannon this big before, 120 feet long. A longer barrel would give the gases more time to push on the probe. So, in theory, the probe would leave the barrel faster and go higher. But it was dangerous.
We were quite tense and excited over whether or not our assembled gun, the double length, would hold up under the firing.
The new gun worked. The scientists used a more explosive propellant. They pushed in more than 1 ton, and they made the probes lighter. So the probes shot out faster and went up higher. Bull's success won him funding from the Canadian government and attracted increasing attention from the U.S. Army. They had him conduct secret tests of high-altitude exploding shells for an anti-ballistic missile system. But Bull's passion still was space. Finally, in November 1966, he got there. Bull had developed his gun launches with just a fraction of the billions spent on America's rocket program.
One of the things that fascinated Bull is that you can do the launches for a fraction of the cost of a rocket launch. He was saying, for example, that he could launch a satellite for something like $3,000.
To launch a satellite into orbit, Bull planned to combine the advantages of rockets and cannons. He would launch a small rocket from the cannon. 17 miles up, the rocket would ignite the first of its 2 stages. Further up, the second stage would accelerate to orbital altitude and orbital velocity, 18,000 miles per hour. But to do this, Bull needed the cannon to shoot the rocket out at speeds he'd never achieved. The key was to design a new propellant which maintained maximum pressure longer.